Okay, so this quick video is going to explain the similarities and the differences between positive and negative feedback. So let's get started. All right, so before I even get into what is the difference between the two, I do want to address a myth that positive feedback is good for you and negative feedback is bad for you. It's very much a myth. The reality is that both are crucial to our survival. Remember that both of these are natural processes that are maintained by the body. Well, let's go ahead and actually start with negative feedback. Negative feedback is what regulates most of the homeostatic levels of the body. And it's the process where our body will reverse a change that may be occurring. And this is what keeps our bodies at set points. For instance, our temperature has a set point of about 98.6 degrees. If we get too hot, we will sweat. If we get too cold, we'll shiver, all designed to keep us at our set point. I want to start with an analogy of negative feedback in your home. Somewhere in your home, centrally located, you have a thermostat on one of your walls. And maybe tucked away in the utility room is the furnace. Well, connected to the furnace are all the heating and air conditioning vents and ducts. And there's a wire that connects your thermostat to the furnace. Well, we often set our thermostat for a desirable temperature that we want to be comfortable at, maybe 77 degrees Fahrenheit. But maybe it's really cold. Maybe it's only 74 degrees inside your house because you left the windows open. Your thermostat will send a signal to the furnace. The furnace will respond by pumping out a bunch of heat around the house. And over the next few minutes, your home will warm back up until it gets back to the desired set point. At that time, everything turns off. Great example of negative feedback because your home responded to the cold temperature and performed an action to warm the home up. So let's stay on the topic of body temperature and explain how our body temperature is a great example of negative feedback. So we have a set temperature of about 37 degrees Celsius or 98.6 degrees Fahrenheit. But let's say, like the woman in the picture, you go for a walk. You know, the longer you walk, the more heat your body generates. And so now the woman's temperature is up to 37.8 degrees, 38.1 degrees. We've all experienced what happens next. We start to produce a lot of sweat. Sweat is designed to cool us off, but how? How does sweat actually cool us down? So as the sweat begins to evaporate, heat is carried away from the body. So the more sweat that we produce, the more sweat will evaporate, the more heat will be carried away from the body. And over the course of time, we get back to the 37 degrees Celsius, the set point. Great example of negative feedback because the body's temperature was returned to the normal set point. Well, the opposite is true. What if we're outside on a really cold day? The longer we're outside on a cold day, our body temperature drops 36.6, 36.2, and so the longer we're outside, the colder we get. Well, what happens in this case? Well, this is something that we've all experienced. When we're really cold, we start to shake and shiver. The shaking and the shivering generates heat. You know, muscles are rubbing, producing friction, which generates heat. And the longer we shiver and shake, of course, eventually we produce more and more and more heat until eventually we get really close to the set point. And when we finally reach that set point, 37 degrees Celsius, a signal will be sent to the brain and the shivering will stop. We've returned to the normal set point. That's a great example, again, of negative feedback. Negative feedback returns the body to the set point, in this case, 37 degrees Celsius. So how about another example of negative feedback? You know, how the body maintains a level of blood sugar or blood glucose is a great example of negative feedback. There's a small amount of glucose in our blood. That's what the G represents in my picture up here. And so this represents the normal amount of blood sugar. But anytime we have a meal, after our meal is digested, the glucose enters into the bloodstream. At this point, we have an elevated blood sugar level. And so an alert will be sent to the brain. The brain will send a signal to the pancreas. So the brain will, here's our pancreas. The brain will send a signal to the pancreas, and the pancreas is going to respond by releasing the letter I in my animation. The letter I stands for the hormone called insulin. Insulin is going to help lower the blood sugar back to that normal 0.1% level. So here we are back in the area where we started. We see again the elevated blood sugar. Again, our person just had a meal, and the pancreas just released a bunch of I for insulin. The insulin will attach itself to these little doorways, these little channels that are found on cells, and the insulin causes these channels to open. And once the channels are open, I hope you can predict what's going to happen next. So the glucose is going to diffuse through those open channels. Well, I hope you see what that did to the level of sugar in the blood. That reduced the blood glucose level back to its normal 0.1%. So this is how, this is again a great example of negative feedback here. It's simply because negative feedback reverses the change. The change is that the blood sugar became elevated, and so the body responded in a way to lower the blood sugar back to its 0.1% set point. Great example of negative feedback. Well, what about the opposite? Again, here's our 0.1% normal blood sugar. But let's say, a person's really been exercising for a real long time and they're running out of fuel. Glucose is like a fuel. So let's say you're over exercising and now we're getting really low on on glucose. So our blood sugar, it's not normal anymore. We now have a reduced blood sugar. Again, there's a way to combat this. So in the case of having reduced blood sugar, the brain will receive a signal that the blood sugar is too low. Instead of the brain responding and sending a signal to the pancreas, in this case, because the blood sugar is too low, the brain will respond by sending a signal to our liver. Here's a picture of our liver, and our liver has a bunch of stored glucose in it. And so the liver will respond by releasing extra storages of glucose into the blood. That brings the level back up to the 0.1%. And this will continue, the liver will continue to release the stored amounts of glucose until the blood sugar is back to that 0.1%. Again, great example of negative feedback because the body has responded and returned the body to a normal set point. So I hope after going over those examples, we can dispel that myth that negative feedback is bad for you. Again, the reality is both are crucial. Both negative and positive feedback are crucial. Well, let's actually shift our attention now to positive feedback. This is a feedback where a rapid change is needed. And this is a process where your body will actually encourage whatever the change is, it will encourage the change and allow it to proceed even faster. And so the body will actually move away from a set point. So let's go over some examples of this. So I hope a good analogy of positive feedback in our home comes to the use of smoke detectors. You have a smoke detector in every room of your house, and let's say a fire begins in the living room. Well, the smoke detector nearest to the fire will probably be the one that activates first and turns on the loud, piercing alert noise. But positive feedback is different than negative. Positive feedback encourages the alert. So one by one, all the other smoke detectors will turn on and activate the loud, piercing noise to hopefully wake everybody up to get everyone to safety. Notice how the alert was amplified. It was encouraged. It was increased. So let's look at a biological example of positive feedback. A great example are the pregnancy contractions that a woman experiences before giving birth. So at first, pregnancy contractions or the muscles of the uterus begin to stretch and contract in a very slow manner. And when the contractions begin very slowly, an alert will be sent to the brain. The brain will respond by sending out a hormone. The hormone, by the way, is called oxytocin, and that's what the black triangles represent. Well, how do the muscles of the uterus respond to oxytocin? The muscles of the uterus respond by contracting even faster with the hopes of delivering the child even quicker. So the contractions are not stopped and returned to zero. That would be negative feedback. The contractions are promoted and allowed to proceed. So again, this is why it's a great example of positive feedback. So how about another example of positive feedback? Another great example is what happens when we're injured and we form a little blood clot. So here's a case where a person got scratched and they're starting to bleed. So those damaged, injured cells begin to release little proteins into the blood. And what's the purpose? Why would they do this? What is the goal? If you think about it, the goal is to plug that injury. So those damaged cells released a bunch of proteins that will actually attract platelets, and platelets are very important in stopping stopping the bleeding. Then the platelets respond by releasing more proteins, which attract even more platelets, and then they respond by releasing proteins, which attract even more platelets, and then those platelets respond by releasing proteins, which attract even more, and eventually enough platelets kind of close and fill in this injury where the person stops bleeding. But again, a great example of positive feedback because the change was encouraged. The clotting was encouraged and allowed to proceed at an even faster rate. It wasn't turned off. So here you go. We've reached the end. I hope this was a good understanding of the differences between positive feedback and negative feedback. If you have any questions, post them in the comments below and perhaps I can get a chance to answer them. Thank you and good luck.